Yesterday we talked about independent versus dependent variables. We are going to continue talking about those, but we're going to transfer that to function word problems. So, these are the important things to remember when it comes to independent versus dependent. Independent comes first. Dependent comes second. Independent represents our x variable. It is our input. Independent, input. Dependent represents the y variable. And then these spots I want you to put a star next to, and we are going to highlight. These are the questions that you should be asking yourself. First, is time in the problem? Because time is the clue to the independent variable. And is money or totals in the problem? Because those are often dependent. And then when you do your sentence, it kind of flips around. So when we are writing equations from word problems, step one is we need to identify the independent and dependent variables, then put them into the linear equation. So our equation should always be in the form y equals something. There should always be something multiplied by x, and there may be something added. So like here, we have something multiplied by x. Sometimes there's something added, sometimes there's not. The dependent variable is our y, independent is our x. So let's first just look at writing equations before we get into the word problems. All right, VHHS is charging $10 per entrance ticket to the spring musical. Write an equation to find the total amount earned for selling tickets. So first off, I'm just going to label this here right away. My independent is x. My dependent is y. And I know that my equation should always be y equals. Now we got to go back and find our variables. So the first question that we ask is time in the problem. Do we see time anywhere here? No. So I'm going to go straight to question number 2, which is, do we see money? Yeah. I see charging $10. Right? And it also says the word total amount earned. Okay? So we're charging $10 and they're earning money. So our dependent variable is the money earned. You can't just write money. You have to write, are we earning money? Are we spending money? That's a big difference. Well, how are they earning money? They are earning money by selling tickets. So the number of tickets sold is our independent. Now when we're writing our equation, I'm going to go back, I'm going to look for the number or numbers that are given to us in the problem. Okay, we see $10 is given to in the problem. It's $10 per ticket. So it's $10 times the number of tickets, which is represented by x. Number 2, Mrs. Carlson discovered that the average adult person breathes 14 times each minute when they are not being active. Write an equation to find the total breaths a non-active adult takes in minutes. All right, so first thing I'm looking at is I'm going to label my independent as my x, my dependent is my y, my equation should be y equals. First question I ask myself is, do we see time anywhere? Well, I see minutes. So that tells me time is always independent. So the number of minutes should be our independent variable. Now I look back, and then for dependent, we are always looking for money. Do I see money anywhere in this problem? No. So I have to ask myself here, what's happening each minute? Well, it says person breathes, and if we look at the question, write an equation to find the total breaths. Okay, total is our dependent. So the total breaths, or our number of breaths, is our dependent. Now I'm going to go back in my problem. I'm going to look for the numbers that are given to us. Here the number 14 is given to us. 14 times each minute. Minute is our x, so it's 14 times x for our equation. Number 3, Mason is learning how to play the piano. He plans to learn 2 new songs each week. Write an equation to find the total number of songs learned over time. So again, I'm going to label my independent as X, my dependent is Y. My equation should always be Y equals. First question I asked, do we see time in the problem? I see the word week. Week tells me time, which is our independent, so the number of weeks is our independent variable. Second thing for dependent, I always look for money. I don't see money anywhere in here, so I'm just going to ask myself, what's happening each week? Well, he's learning songs. We're talking about songs. And if we look at the question, it says, write an equation to find the total number of songs. So, the number of songs is our dependent variable. Going to go back in the problem, look for the number given to us. I see 2. It's 2 new songs each week. So 2 times the weeks, which is X, so 2X. All right, now that we've practiced just writing equations, we're going to look at how we combine all of this together. So Miss Cribbage bought tickets to the high school basketball game for herself and all of her friends. She paid $7 per ticket. Write an equation and make a function table for the total amount spent. So first thing, again, I'm labeling my independent should be X, my dependent should be Y. The equation should be Y equals. I'm going to go back, ask myself the questions. First off, is time anywhere in this problem? No, so that's not my independent variable. Go back then for dependent. Do we see money anywhere here? Yeah, she paid $7. And if we look at the question, write an equation to find the total amount spent. So, she's paying money, she's spending money, not earning it. So our dependent is the money spent. Well, what is she spending money on? She's spending money on tickets. So the number of tickets bought is our independent variable. Go back, look for the number given to us in the problem, which is 7. It's $7 per ticket. So 7 times tickets, which is X, so 7X. This equation is so important. Because if this equation is wrong, everything that follows is going to be wrong. Your table is going to be wrong. Your graph is going to be wrong. And then these questions at the bottom are going to be wrong. So make sure you're being really careful when you're writing that equation. So now we're going to take this equation and we're going to plug it into the table. Remember that we said you can plug in any input values, but first off, we want to make sure it's going to fit in our graph. And I like to work with easier numbers. So every single time I'm plugging in 0, 1, and 2. So we are going to plug in to our equation y equals 7 times our x value of 0. 7 times 0 is 0. So the output value that we get is 0, which means our ordered pair is x is 0, y is 0. Now I'm going to plug in 1 for x, so we don't know y. Y equals 7 times our x value, which is 1. 7 times 1 is 7, so our output is 7. So our input x is 1, our output 7 is our y value. And the last one, plugging in 2 for x. Y equals 7 times our x value of 2 equals 14, so our output is 14. So for our ordered pair, x is 2, y is 14. Now we're going to take these and we are going to graph them. Okay? So, first off, I want to label my axes. My x value is talking about the number of tickets. You should always be going back to the top here. Okay? So x is our number of tickets. I'm going to label my x-axis, which is the horizontal axis, as number of tickets. You have to label it. It's going to help you double check your work too. And then our y-axis, our y value is representing the money spent. So I'm labeling that axis money spent. Now we're going to plot these ordered pairs. 0, 0, 1, 7, 2, 14. And then I'm drawing my line connecting these. Remember, there should be arrows on both ends to show that it technically goes on and on forever. Now, we have to, and it's important to note this part, use the equation to solve each problem below. So right away in these, I'm going to write y equals 7x. That is the equation we are given. Okay? So, let's look at this first question. How much total money would Miss Krippinger spend if she bought 15 tickets? So, first thing I'm going to do is I'm going to circle the number that is given to us in the problem. She bought 15 what? Tickets. Tickets, if we look back at the top, represents our X. So what I'm going to do is I'm going to write a little X underneath this. And then if I look at the question, it says how much total money. That means we are solving for the money. So our X value is what we know. We are going to plug that into the equation, 15, where X is. So we don't know Y. We know that it equals 7 times our X value of 15. 7 times 15 is 105. So we were solving for how much total money, so Y equals $105. For B, if Miss Krippinger has a total of $63, so that's talking about dollars. If I look back at the top, our money is talking about Y. So this is going to be plugged in for Y in the equation. So 63 for Y. We don't know what X is. So now we have an equation we need to solve. X is being multiplied by 7. I'm going to divide by 7. 63 divided by 7 is 9. What was I solving for? It says how many tickets. So 9 tickets. All right, let's do one more of these. All right, Percy gets $5 for each chore he completes. Write an equation and create a function table for the total amount earned. So, then first thing I'm going to do is I'm going to label that our independent is X, our dependent is Y, our equation should be Y equals. First thing I look for, do we see time anywhere in this problem? Nope. So I'm going to go straight to money. Do we see money? Yes. I see $5 plus it says total amount earned. So our dependent variable is the money earned. Well, how is Percy earning money for each chore? So our independent variable is the number of chores. Go back to the problem, find the numbers that are given to us in the problem. We're given $5 per chore. Chores are X, so 5 times X is our equation. So I'm going to plug that into our table here. Again, the 3 values I'm going to plug in for input are 0, 1, and 2. So let's plug it in. Y equals 5 times our X value of 0, which is 0. So our output is 0. So our X value is 0, our Y value is 0. Plug in 1. Y equals 5 times our X value of 1, which is 5. So our output is 5. For our ordered pair, X is 1, Y is 5. And the last one, Y equals 5 times our input of 2. 5 times 2 is 10. So our output is 10. Our ordered pair is X is 2, Y is 10. Okay, now remember we got to label our X-axis. X is represented by chores, so number of chores. And our Y-axis is representing the money earned. Now I'm going to plot my 3 ordered pairs. 0, 0, 1, 5, 2, 10, and draw my line connecting those. And now let's go into solving these two problems. Again, we have to use the equation to solve each problem below. So my original equation is y equals 5x. I'm going to write that immediately for both of these. Now in this problem, if Percy earned a total of $45, how many chores did he complete? So $45 is representing y, so I'm going to write that this is y. That is going to be plugged in to y in our equation. So 45 for y, we are solving for x. So I'm going to solve this equation. X is being multiplied by 5. The opposite is to divide by 5. X equals 45 divided by 5 is 9. Well, we have to include units in our answer. What were we solving for? The question says how many chores. So 9 chores. And the last one, how much total money would Percy earn if he completed 8 chores? So 8 chores, chores is representing our x, so we're going to plug in 8 for x into our equation. So we don't know y, we know that x is 8, and we're going to evaluate that. 5 times 8 is 40. What were we solving for? The question says, how much total money? So our units here is money. Go ahead and show that you've completed the notes, and then you can move on to the homework.